Chapter 13, Data Types and Structures. Let's see what we are going to learn today. By the end of this chapter, you should be able to select and use appropriate data types for a problem solution. Those are the integer, real, char or character, string, boolean, date, array, file. Show understanding of the purpose of a record structure to hold a set of different data types under one identifier. Write pseudocode to define a record structure. Write pseudocode to read data from a record structure and save data to a record structure. So, write pseudocode to define a record structure. We'll be learning how to write pseudocode to define a record structure. What is this record? We are going to learn. And to read data from a record structure and save the data to a record structure. So both ways we will be learning. And you will learn how to use the technical terms associated with arrays, including index, upper and lower bound, the terminology. Select a suitable data structure, that is 1D or 2D array, to use for a given task. Write pseudocode to process array data, including sorting using a bubble sort and searching using a linear search. There are many sorting algorithms and search algorithms, but we'll be learning these two. Show understanding of why files are needed. Why do you need files? Can't we do only with arrays? Write pseudocode to handle text files that consist of one or more lines. Text files will be handling text files. Up to now, we use a text editor to type or edit or delete text from a text file, a notepad. Example is notepad. But today we'll be learning how to do it programmatically. Understanding that an abstract data type, ADT, is a collection of data and a set of operations on those data. So abstract data type. So there are different types of data structures. Show understanding that a stack, queue, and linked list are examples of ADTs. So under ADTs, we'll be learning stack, queue, and linked list. Describe the key features of a stack, queue, and linked list, those three, and justify their use for a given solution. Which one will you use? Will you use stack or queue, and why? Use a stack, a queue, and linked list to store, add, edit, and delete data. Describe how a queue, stack, and linked list can be implemented using arrays. So let's go into details. Data types. You have a thing called primitive data types. Can be defined simply by commands built into the programming language. When you are using a programming language, you can say string. You can just simply say this name is defined as a string. Then it understands. Those are the primitive data types. Also known as atomic data types. So that's the basic things, atomic data types. Those are integer, real, char, and boolean. That is integer, as you all know about these things by now. We have done this, but then integer is a number, whole number. Real is a number with decimal points, places. Then char or character is a structure with one single character, text character. And boolean, which can have only true or false. Then there are further data types further than this. Two things called string and date. String is a sequence of characters. So if character is just one, like A, B, but string is a sequence of those things, like collection. So you have A, B, C, D, E, F, a name, address, email address. Those things all come under string. Empty string. String without any characters. Date can be written as 1124 or 1/1/2024. But in order to enable calculation of dates, the date has been defined as a date type. So when you have this date data type, right? The date as a data type, it helps you to do some functions. Since it is defined as in a different format, a standard format, it can perform some functions. That is the advantage of using this format. The data type, date as a data type, not just a string. You can have as a string the date the way you want, 01/01/24 or 01/01/2024. Anyway, but those things you can't do any carry out any functions with them. For example, you can, when you have the date of birth of a person, you can calculate the age only if that date of birth is stored as a data format, right? Data type, the date data type, the date data type. Then you can calculate the age. If not, if it is stored as a string, then you are not able to do that. So let's have a look at these, the data types and structures here. Name. If you say Harry, it's a string. Alphanumeric characters. You can have even numbers, right? So age 13, 12, it's an integer. If you are not using decimal points, the integer. Then average 89.75 with decimal points is real. And gender, M or F is character. Either M for male. If you're using F for female, then it comes under char or character, single character. Then let's see what we have here. I have given in a table form these data types: integer, assigned whole number. So these are being repeated because it's important to know. And in a question, you must know exactly what it is. Real, assigned number with a decimal point. What is signed? Signed, the negative sign, positive sign. If it is a negative sign also, it can be integer. Positive also can be integer. Real also can have signed number with a decimal point. In character, a single character like A, capital A, simple Z, or 9. String, a sequence of zero or more characters. It's a sequence. Zero character is this. More than zero. There are 3 characters here: A, B, C, or Sri Lanka. Boolean, the logical values, true or false. And the date, a date consisting of day, month, and year, sometimes including a time in hours, minutes, and seconds too. Right. There's a task. Look at the identifier tables in chapter 12, 12.06 and 12.09 to 12.12. Give the data type that is appropriate for each variable listed. So here they are. You have to, what is the task? You have to give the types. Give the data type that is appropriate for each variable listed. Right? So miles, what? What is the data type, appropriate data type? Miles could be integer. Integer, it's a number of miles. If you remember, the question was input number of miles and convert it to kilometers and output. So this kilometer is the result from using given formula, but this has to be real. Kilometer you can't put because there is a formula to convert. You might get the decimals, so you have to give a real for that. what is this? Biggest so far. Stores the biggest number input so far. So that also can be real, because we don't know what number the user will input, with a decimal or without decimal. And the next number to input, same, real. Counter stores how many numbers have been input so far. Counter also, can you put real? No, you count 1, 2, 3, 4, 5, not 1, 1.1, 1.2. You don't do that. So counter can be integer. Secret number, the number to be guessed. That also we don't know what the user will input. So better to have real for that. Or integer, depends, right? Number of guesses. The number of guesses the player has made, again, it has to be integer. You don't have half guesses. So 1, 2, 3, first guess, second guess. Guess, the number the player has input as a guess. So that depends on the game. The secret number, if the secret number can be a real number, then the guess also can be a real number. Running total stores the number of the numbers input so far. This is from another table. In fact, 12.10 is not needed, but then let's do running total can be real. Counter, as we have already discussed, it's an integer. Next number can be real, and average has to be real, because average means you divide by the number and then you get the decimals. So that done. Now this 12.09 is here, 12.0. This is 12.06, 9 and 12.12. Symbol. This is for the displaying of either pyramid or some characters. Symbol is the character symbol to form the pyramid. Okay, this is the pyramid question, if you remember. So what is the symbol? So for that, you have to use character. Just one symbol. Max number of symbols, that also can't be real. It has to be integer. Then number of spaces, number of symbols to be displayed, all those have to be integer. Now let's come to this type, record type. So let's see what happened here now. We learned just a few, the data types, the primitive types and further types. And now we are coming to record type. Variables of different data types are a logical group, such as data about a person, name, date of birth, height, number of siblings, whether they are a full-time student or not. So record, why do they call it record? Yeah, it's the record. This is like a table, and the rows are called records. Or tuples, if you remember the database, chapter 11, database lesson. So this, record is like this. The record has fields, right? Admission number, first name, last name, date of birth, record. So that is also type. And just to mention this, record has fields and they are on the hard disk, and array is elements. If you have an array, then those are elements. But in a record, they are called fields, okay? Right? So in this case, we are using name as string, date of birth as date, height as real, number of siblings integer. You don't have 1.5 siblings or like that. So full-time student, it's Boolean. Whether he's a full-time student or not. True, if so. If he's not a full-time student, then false. We can define one data type to suit all above data. So instead of having all these things, we can just have one. We define them as one lot. Give a label and make all these things available under that. We call it a record type. It is a user or programmer in this case. The user in when you are programming, the user is the programmer. So we call it user-defined type, not the ones that are available in the language. Record type is also known as a composite type. All right. Composite type, because it's a like combination of other types. Right? Composite type. Defining person record type for above examples. So we are going to now for this name, date of birth, height, and all that are in respect of a person, no, related to a person. So we will call it person type and define. This is the way to define the person type, a record type in the pseudocode. Start with the word type, then the name given. We are giving person type. And all these things come here. Name, colon. This is just English we wrote here. You can't put a dash. You have to put a colon. That is the syntax in pseudocode. Name as string, date of birth as date, height as real, number of siblings as integer, is full-time student. This is like, that's a standard way of how programmers use these variables or identifiers. Is he a full-time student? So that is Boolean, right? And this is the end. So you can type end type. The indentation, important, remember, as usual. When we want to use a variable of this type, so now we have defined. When we want to use that type, what do we do? When we want to use a variable, declare, the word declare has to come as like normally we say declare name as string. So in this case, declare person. We will create like a copy of this, right? Copy of this and name it as person, as person type. This new identifier we are creating or declaring person, use this data type. Normally we put string, date, real, but here we are using person type. So where is this person type? The language doesn't know. So we have it here, person type. So this person here, this identifier, the record will have this structure and the functions associated with each field. Now we can assign values using dot notation. For example, person dot, right? A person, when you say we are referring to this structure, person dot name. So that we'll be taking this field from the person and assign the word Fred, the name as Fred. So you have to, as usual, you have to give the inverted commas and the arrow for the assignment sign. Remember, left side. Person dot number of siblings will be 3. Person dot is full-time student, true. So we can assign values like that. Then to output a field of a record, output, that's usual, nothing, no change in that output. Then the person, we have to refer to this and the dot and name. If you want the name of this person, Fred out, you have to say output person dot name. Not so difficult. So just have a good look again, what we learned now. Dot notation. The structure, dot, and the field name. All right. Here is a task. Write the declaration of a record type to store the details of a book, title, year of publication, price, and ISBN. Write the declaration of a type. So how do we do that? Here it is. Let's look at the question. Write the declaration of record type. So start with type and we'll give the name book type. We can give anything. This is not a standard thing. You don't have to say person type for person and book type for book. No, we can say my book even here. Type my book type. Write the declaration of record type to store the details of a book. These are the things to store, or the fields are these: the title, year of publication, price, and ISBN. So there are 4 fields in that. They are here. Title as string. Year pub. We can have our own names for these identifiers. Year of publication integer, because we are not going to have any functions for that. And also you can see the date given here. The data is given. The next section is write the statements required to assign the values computer science 2019, this amount, and the ISBN to the fields respectively. So the second field is year of publication, the 2019. So you can't do any functions, and the format is different from the date format. So we use it as integer. Then price as real, because there can be decimal points here, 44.95. And ISBN as a string, because ISBN you can even, as if you can remember, you can even have X with the remainder, the final calculation, if the remainder for the remainder, and then, yeah, the final calculation gives you 10, because you are dividing by 11, there is a possibility of having a remainder of 10. So in that case, or if you the remainder is 1 and then you subtract 1 from 11, the final step, then you get the check digit as 10. You can't have it. So if it is 10, we substitute that with X. I hope you remember that. So in that case, you can't have it as integer. So we have it as string. N type, that's it. Afterwards, write the statements statements required to assign the values. So then, first of all, we have to declare. You can give my book or something, declare my book, or here in this case, I have put book as book type. So the book type, again, these will come into this. Then you can use the dot notation and say book title, this one, equals computer science. The data is given here, no problem. Book.year is 2019, book.price is 44.95, book.ISBN, this, right? Then, after that, arrays, another structure, list or table or matrix, right? Array elements are addressed using an array index. The structure has an index. If you want to address any particular element, we learned that the arrays have elements. Array as elements instead of fields as in records. Right then, array elements are addressed using an array index. A list is a one-dimensional, 1D array, and a table or matrix is a two-dimensional or 2D array. So 1D array, there's just one column. You can look at it that way, just one column and just one coordinate to address any element. Whereas a matrix or a 2D array, more than one column. Can be 2, 3 columns, 4 columns, any number of columns you can have. Then there'll be 2 coordinates to address a particular element. Then look at the key terms here. Array index, row or column number of an individual array element. Row or column number of an individual array element. Upper bound, the highest number index of an array dimension. low bound, the smallest number index of an array dimension. So we have the dimensions separately. For a row, you have the upper and the lower. For the column also, you have upper and column. That is for 2D array. Just 1D array, just one set. One lower bound and one upper bound. Then one-dimensional arrays. Lower bound, 1. Upper bound, the last element number. So lower bound is always 1, the first element. Index number is 1. In programming languages, you start with 0. But let's try to stick to 1 in pseudocode. It's easier. Declare. This is the way to declare an array. 1D array. Declare. The word declare has to be there. Then the array identifier, the name. Then as the colon is there, as array. The word array has to be there. Then the lower bound is the number, the first element. So usually it's 1. And then colon again a colon. 1 to upper bound is maximum number of elements. So if there are 10 elements, this will be 1 colon 10. And then what is the type of data type? You have to put of. The word of is pseudocode keyword of, and the data type 1D array. So let's look at these, a few declarations and their meanings. Declare list 1 colon array 1 to 3 of string. So there'll be 3 elements in this array and type is string. Here 0 to 5, there'll be 6 elements. 0 to 5 is 6. 1 to 100, 100 elements, and 0 to 25, 26 elements of character, of character. I would like to ask a small question here. For what would you use this array? The list 4. Time to think. Think a little and see whether you can get the answer. What? 26 characters. The alphabet. If you want to store the alphabet, that will be the best way, isn't it? Use a list 1D array. 1D array. So it's interesting when you want to learn these things, always try to connect or observe, see the patterns, and it's called pattern recognition under computational thinking. Chapter 1 we learned, right? Basic thing. Now here, accessing 1D arrays. Array identifier, that's a name like list 1, and within square brackets, the index number, the element number. The nth element within the array mylist is referred to as mylist within square brackets n. That's the nth element. Example, if the name is nlist, name of the array nlist, 25 equals 0, the meaning is set the 25th element to 0. In this case, A list 3 equals D, set third element to letter D. Okay, and here is a worked example. Working with a one-dimensional array. The problem to be solved. Take 7 numbers as input and store them for later use. We could use 7 separate variables. Like we used to do n1, n2, n3, like that. However, if we wanted our algorithm to work with 70 numbers, then whatever. n1, n2, n3, n67, n68, n69, n70. It's not practical. And not only 70, you can even have more in certain problems. For example, then setting up 70 variables would be complicated and waste time. Instead, we can make use of a data structure known as a linear list or a 1D array. Something like this we can have. Just one name then. Here the name is MyList. And the array elements are there, 70 or 700 even, no problem. This array is given an identifier. That's a name. For example, MyList. And each element within the array is referred to using this identifier and its position. That's the index within the array. For example, MyList within brackets 4, square brackets 4, refers to the element at position 4 in the MyList array. So position 4 is this, 41. If we are counting the element at position 0 as the first element, MyList 4 refers to the fifth element. So it's this. But if it is from 1, then it will be this. Right? 1, 2, 3, 4 or 0, 1, 2, 3, 4. That's a difference. If you're starting from 1, 2, 3, 4, or starting from, if then in that case, 1, 2, 3, 4, it will be 7. But if you're starting from 0, then it will be that. If you're starting from 1, it will be this. So that's simple. It's a matter of counting. But this is the way to address them. MyList 4. We can use a loop to access each array element in turn. If the numbers input to the pseudocode algorithm below are 25, 34, 98, these are the numbers, and up to 5, then the algorithm will produce the result in figure 13.01. That is this 13.01. This is the result. If you input these numbers into this. So how do we do that in pseudocode? For, you remember this loop for index equals 0 to 6. 0 to 6. And input, straight away you can give the location. MyList index. So the first number 25 will go into this, second one 34. Likewise, it goes on. Just one input statement. No 7 input statements. If you are using N1, N2, N3, then we have to input N1, input N2, input N3, likewise. So here this is a loop, and within that just one input statement. All right, now let's look at a worked example. Working with a one-dimensional array. The problem to be solved. Take 7 numbers as input and store them for later use. So we saw this now. Then what happens? Afterwards, 13.03 is a task. It's a task. So define 2 arrays, one for your friends' names and one for their ages, as shown in figure 13.02. This is the figure. Array called name for your friends' names and then their ages respective. You will learn that this index, using this same index number, you can connect this. Matt is 15 years, Fred is 16 years, like that. Let's see how we can do that. Define 2 arrays, one for your friends' names and one for the ages as shown in page 30.02. But this is figure 30.02, but this is not for that. What I said, connecting. This is just to define 2 arrays. So how do we do that? No, that is 13.03, sorry, 13.03. So like this, you can declare 2 arrays declare my list, or you can say let's do this like this. Declare. I have taken as only 5. Let's make it. We'll use the same name, right? Only we'll make it names. That's more like appropriate. Array 1 to, let's make it 19, 0 to 9, 19, so that it will be just the task, because when you are given a task, you have to do accordingly. So 0 to 19 of string. And then what about the ages? Declare ages, or age. For that, of course, age. As array, and the lower bound and upper bound, again 0 to 19. So to total of 20 of what will this be? These are integer, of integer, data type integer. Right. So then that's the answer to this. Define 2 arrays. Define is like to declare, right? So having done that, let's go to another worked example, searching a 1D array. So now you know how to define arrays. Define arrays, and then you know how to insert also we did, like input here. In a loop, you can use the lower bound here and the upper bound there as the range. Then input my list. This will be repeated so many times, 7 times in this case. And the data will be assigned to these elements. Now we are going to do a search. For example, now if you want to find out Fred. Is Fred there? First of all, is Fred there? And if it is there, to output, say, Fred is available at 1. Or in a later case, you can say Fred is 16 years old. Very interesting. The problem to be solved. Take a number as input. Search for this number in an existing 1D array of 7 numbers. Right? Worked example 13.01, we saw this one. The numbers are there. And then let's say, for example, we want to search for 7, number 7. Start at the first element of the array. Is it equal to 7? No. And check each element in turn until the search value is found. So if until you find the 7, you go on. First one is not, that is 20, 34, 25, or that numbers, no, 98. When it comes to 7, then it's found. Or if it is not found, say if you put 1,000, it's not there in that list, end of the array. In that case, you will reach the end of the array is reached. This method is called a linear search. If it is not found, end of the array, you know that it's not found. This is called linear search. In sequence, check one by one. Go on checking from 1 to the end until you find it. So what are the identifiers and the explanation? This is called the identifier table for linear search algorithm. Linear search algorithm. So let's see the identifier table. What are the identifiers required? My list. That's an array. Name of the array, 0 to 6. That means 7 elements. Data structure. That's a 1D array. If you have like this, just one lower bound and one upper bound, that means 1D array. To store 7 numbers. Then max index, an integer, and the number of elements in the array. So in this case, max index will be 7. Search value, integer. The value to be searched for. Found, it's a Boolean variable. True if the value has been found. False if the value has not been found. So we are using a flag, which is very useful. Index, integer, index of the array element currently being processed. We can use that for the accessing of elements. So we'll start like this, max index equals 6. That's the number because we are starting from 0. Max index is 6. Input search value. What is the search value you want? 34, 25, or 98, or 7, whatever the number you want. Then found equals false. So starting, before we start the search, we set the value of found to false because you'll be using that as a condition. You will see in a little while. And index equals -1 because we are starting with this, which is useful for the algorithm. It's a repetitive thing. So as we start, you add 1 to it so that the index becomes 0 so that we can access the first element. Repeat all these things until found equals true. Right? At the moment it's false, so this will go on until it becomes true. Somewhere we'll be changing this to true. Until then, or else index greater or equal to max index. If the index you're adding 1 to index. So starting from 0, you go on. If it becomes 6 and still if it is not found, that means not found. That is end of the array. So until either found equals true or the max index is reached. Right? If the last one is the one, in that case also, this will be true because when we find it, we make it true. So let's see how we make it true. If my list index, so we are referring to the first index the first time. First time, if my list index, because now we have made the index 0 here, first time, equals the search value. In case if it's the first time it's true, I mean it's found, it's equal, then we make the value of found to true. And then when it checks this condition until found equals true, so now it's found, so this will end. The loop will end. Supposing it's not the first element. First element is not equal. If my list index not equal to search value, then this is not true, so nothing will happen. So repeat. Check for the two conditions. Is the found equals true? No, found equals still false, the initial value, because this didn't happen. Still, it is false. And has the index value reached max index? No, because it's still 0. Then you repeat. Repeat, this will become 1. Then the second element will be checked, and so on. It goes on. After the loop is over, we'll check whether the found equals true. If found equals true, then you know that we have found it somewhere. Output, value found at location and the index. That index value where we stopped, because this will exit the loop. When found becomes true, this will exit the loop. So that is the last index value is the location of this value in the array. Else, that means found is still false. Output, value not found, because we have reached the end. Reached the end of the loop and value not found. The complex condition to the repeat until loop allows us to exit the loop when the search value is found. Using the variable found makes the algorithm easier to understand. Found is initialized first set. Initializing is the first value set to false before entering the loop. and set to true if the value is found. If the value is not in the array, the loop terminates when index is greater than or equal to max index. That means we have come to the end of the array. Note that using max index in the logic statement to terminate the loop makes it much easier to adapt the algorithm when the array consists of a different number of elements. That is why max is used, max index. So that you can only change here. Change the max index here. If the number of elements is 70, just make it that number accordingly. That's why it's easy. Otherwise, we don't need it. You can straight away say this. Or index greater or equal to 6. We can easily use that. But in that case, you have to change everywhere if this is to be changed. So this is easier. Note that using max index in the logic statement to terminate the loop makes it much easier to adapt the algorithm when the array consists of a different number of elements. The algorithm only needs to be changed in the first line where max index is given value. So linear search, what we did was linear search, checking each element of an array in turn for a required value. All right, now let's look at the task. Task 13.04. Use the algorithm in worked example 13.02 as a design pattern. Write an algorithm using the array from task 13.03 to search for a friend's name and output their age. So this is the one that we have to refer to. Take this as a design pattern. And in this, you have to search for the name and then output. Search for a friend's name and output their age. So let's try to do that in pseudocode. Max index. So we'll have to take this as a design pattern. So max index equals, let's say 19. Yeah, 19. And then input search name. Search name, this one, found equals false. And next is index equals -1. And then repeat index equals index plus 1. If here it is my list, but we are using names. Names, index is the value, index value, equals search value. In our case, we are inputting search name, so we have to use that variable. If it is equal, then what happens? Found equals true. And how long are we going to search? Until found equals true or index is greater or equal to max index. And then once the loop is, now you know what happens. We saw how this works, how it all works. Once the loop is over, we look for the variable found. If it is true, then output search name. Search name is a variable, and in as a constant, string constant, we are writing search name is found, separated by commas, remember. Search name, comma, is, comma, age. Not found, really, in this case, we have to change it, the age. Search name is so many years old, right? So many years old, if it is 14, Fred is 14 years old. Else, that means found equals still false, or index is greater than that. So then what? Not found. Output search name not found. Whatever the name, Anna not found, or Tom not found, and ND. All right. So that's not difficult. Then we come to a very important function, bubble sort. Sorting elements in a 1D array. The simplest way to sort an unordered list of values is the following method. Compare the first and second values. That means if this is the array, first and second means 25 and 34. If the first value is larger than the second value, swap them. First value is larger? No. So no swap. Compare the second and third values, that is the same array, but colored and presented here. The second part, the second iteration. 34 is not greater than 98, so that is also nothing happens, no swap. Then third, compare the third and fourth values. Third and fourth, yes, 98 is greater than 7. If the third value is larger than the fourth value, swap them. So the swap takes place like this. 98 goes to the next one here and 7 goes up. So the result is this. Likewise, the next pair is 98 and 41, and 98 goes down to this one and 41 goes up. Next, also there's a swap because 19 is greater than 19. So 98 goes down, 19 goes up. And similarly, this pair also has to be swapped and 98 ends up here in the last element. So this is just one pass, right? Just one pass. Likewise, it has to do several passes. Here, there are 6 passes. So there are 7 elements. 7 elements. The first pass, what happens is the heaviest one goes down. Right? The largest number goes to the right to the end of the array. So then, next time round, take this as the 98 after first pass, after pass 1. Then you again compare 24 and 34, no swap. Then 34 and 7, yes, there is a swap. So 7 goes there, 34 goes down, and 44. And the next one, 34 is greater than 19, so 34 goes down, and 19 comes up. And 5 and 34. Sorry, in this case, the 41 goes down, right? 41 goes down, 19 goes up, and 41 and 5. 41 goes down, 5 comes up. Then this one, the next largest number is 34, comes next. And next one is 25, 19. And finally, 5 ends up at the top. The lightest element goes up, the heaviest one goes down. That's why it's called a bubble sort, like the bubbles, the lighter bubbles coming up in liquid. So one thing we have to notice is there are 7 elements here. Therefore, you have 6 passes, 6 comparisons. 1, 2, 3, 4, 5, 6. The last one is not compared. There's nothing to compare it. And also, when 98 is sorted already, why should you compare the last 2 here? 41 and 98, no need. 34, 41 and 95 already in order. 25, 34. So the number of iterations in every pass gets reduced gradually until it becomes the last one. So states of the array after each pass. In effect, we perform a loop within a loop, a nested loop. This method is known as a bubble sort. The name comes from the fact that smaller values slowly rise to the top like bubbles in a liquid. So the identifier table is, my list is the array 0, 6, 0 to 6, that is 7 elements. Max index, like the same thing. Integer, counter, count. Now there are 2 counters here because we have, sorry, 2 loops. For the outer loop is I, the inner loop is J. You can use any variable name. Okay? And the temp variable, because you will remember at the very beginning, I may have shown you a Python sample of like A equals 10 and B equals 20. If you want to swap, if you say A equals B and B equals A, both become 20. So it's not successful. You need a temporary variable for a swap because one will override the other. So before overwriting that first element value should be stored in a temporary variable, then taken back to the other one. That's a swap. So the algorithm pseudocode is like n equals max index minus 1, because we are not going to do 7 times. We are going to do 6 times only. We saw that here. There are 7 elements, but we do only 7 because the last one, after this, you don't have to compare. For I, this is the outer loop. For I equals 0 to max index minus 1. For j equals 0 to n, the inner one. First one is max index minus 1. That is a fixed one. Max index minus 1 is 6. But, so that means outer loop will take place 6 times. But inner loop will change this n. J equals 0 to n. N is 6 first time. First time it's 6. And the next time it becomes 5, because at the end of this loop, before starting it again, you reduce 1 from n. That's the way the number of pairs, comparison of number of pairs is reduced every time in the inner loop. Now let's go into details. So in the inner loop, if mylist j, that means 0 first time, greater than mylist j plus 1. Now if this is j plus 1, right? If j is, in other words, j is 0, this is j plus 1 is 1. This is 2, 3, like that. No? So if mylist j, you compare mylist j with mylist j plus 1. If the first element is greater, then you put that into a temporary variable, because we are going to override it with the second variable. So temp equals mylist j. Then you get the mylist j into that one. What is there in mylist j plus 1? The second variable is stored here. And then override the second variable with the temporary stored first element. That is how the swap takes place. So after this, n equals n minus 1 means then you will, this time it's 5. Next time is 4, like that, reduces until the whole thing is finished. After the third pass, the values are all in the correct order. Is that so? See, after the third pass, these values are, the array is slightly different to the earlier one. So 5, 7, 9, 25, 34, yes. Only here, the last swap is 34 and 19 and 25. When 34 ends up here, that's already sorted. But it goes on. Not very intelligent, isn't it? After the third pass, the values are all in the correct order, but our algorithm will carry on with 3 further passes through the array. This means we are making comparisons with no further comparisons need to be made. Actually, no need. Here we have finished, but then we are just going on. Waste of overheads on the memory and CPU. If we have gone through the whole of the inner loop one pass without swapping any values, we know that the array elements must be in the correct order. So if this, now in this case, here, this is not swapped, this is not swapped, this is not swapped. It goes on without a single swap, that means it's sorted. That is the way. That is the indication to find out whether it's sorted. Otherwise, there is no other way to check whether the array is sorted. We can therefore replace the outer loop with a conditional loop. So you don't have to go the whole number of swaps and loops. We can stop. Once it is sorted, we can stop the outer loop. We can use a variable no more swaps, a Boolean variable called no more swaps, to store whether or not a swap has taken place during the current pass. We initialize the variable no more swaps to true. We say no more swaps to true, because then only this will work. When we swap a pair of values, we set no more swaps to false. That means there are swaps. when you say no more swaps false, it's like more swaps is true, but no more swaps is the opposite, so false. At the end of the pass, through the array, we can check whether a swap has taken place. Because when it is, when you are doing the swap, you can change the no more swaps to false. That means there has been a swap. You can't say no swaps because there has been one. If you don't go through this even once, then this true will remain. No more swaps true will remain when you go out. That is the way to decide whether the whole thing is sorted or not. So the identifier table for this improved algorithm, there is a small difference. No more swaps, Boolean. That's all. So go through the same pattern. N equals max index minus 1. Repeat. No more swaps equals true. We make it true. This is an additional variable we are using now. For j equals 0 to n. Okay. So there is no, we are using 1 here. Outer loop is until no more swaps equals true. Unlike earlier for equals, we don't use for. We are using repeat because at the end we can check, are there any swaps? Were there any swaps? If there were no swaps, exit this. So here again, if there were swaps, you start again and make it no more swaps true. For j equals 0 to n, if my list j equals greater than my list j plus 1, then the swap, as usual, the earlier one, temp equals my list j equals my list j plus 1, my list j plus 1 equals temp. And additionally, no more swaps equals false because there was a false swap here. So we change the flag. So n equals n minus 1. That no difference here because it has to reduce. And until no more swaps equals true. So when you come here, true doesn't change because there is no swap. Then it exists. So that is an intelligent program. It's called an intelligent program. So bubble sort, the sort method where adjacent pairs of values are compared and swapped. Task 13.05, rewrite the algorithm in worked example 13.03 to sort the array elements into descending order. That's a very interesting thing. You can stop the video because I'm going to give you the answer. You can stop the video and think how you're going to change this algorithm to make it in the descending order. What we did was in the ascending order. So what do you have to do? Just change this one. No, sorry, not this one. In this, if my list j, instead of greater than, you make it less than. So that the swap will be, when you compare these two, and if this is less than the next one, you swap. That means 25 goes down, 34 goes up. Likewise, the 98 will come up and 5 will end up here. That is in the descending order. So that's easy. Less than. Instead of greater than, you make it less than. So that will be enough for today, for this video. So in the next video, we will do the two-dimensional arrays. Hope you will go through this again and again and improve your knowledge.